Okay, good morning, ladies and gentlemen. We're going to be finishing up our Chapter 2 unit today, 4.2 Day 2, where we're looking at rates of change, slope and tangent lines, applications of limits. Tomorrow you will be reviewing, and we will have our test on Monday this year. So what we're going to do is we're going to, let's tackle one more problem from what we did yesterday here to start out, and we're almost done. Hopefully I can get through this quick, okay? So we have three things here. Number one, we're going to find the slope of the curve, and it's going to be this curve right here at x equals 2. Then we're going to find the equation of line tangent to, so this is tangent line, EOLT, and the EOL is the equation of line normal. Okay, that's the equation of the line normal to f of x, and I'll explain that when we get there. So first and foremost, what we need to do is we need to find the slope of the curve at x equals 2. Well, in calculus, that means please find f prime of 2. What does that equal? And that is my slope. Okay? Now remember, we have two ways to do this. So number one, we have two ways. Okay? The first way we can do this is we can approximate. We can approximate this with a really small interval around 2, meaning we can approximate it from 2 to maybe 2.001, or we could say 1.999 to 2, or the other way we could do it is we could actually sandwich that 2 in there and say 1.999 to 2.001. That's really bad, 2.001. But that's the other way we could do that, okay? Let me get that 0 in there good. Okay, and we would approximate this using our calculator. Okay, the other way, which I'm going to do here, is we can find the exact. Okay, typically I would just use my calculator here, but I feel it's important to show you the exact way a few more times. And the exact way is going to be taking the limit as h approaches 0 of, and our exact way is we're going to take our interval from 2 to 2 plus h, and we're going to let h go to 0. So we're going to take f of 2 plus h minus f of 2, and then of course we're going to divide it by the 2 plus h minus minus 2, and like I said, that's going to turn right into, because our 2's are going to cancel out, so we usually will just go straight to saying over h, and we won't subtract that. Okay, so from here, now I got to take my limit as h approaches 0, and I need to find out minus 2. And I always set this up with parentheses because that is a very troublesome subtraction symbol that always gets forgotten. But I got to take my 2 plus h, and I need to plug it in for each x up here. So I'm going to have 2 times x plus h. We're going to square that, minus 5 times x plus h. It's not x plus h. I'm doing the general derivative. I apologize. I'm supposed to be putting a 2 in there. 2, and then we need to find f of 2, which is going to be 2 times 2 squared minus 5 times 2, okay? And we're going to keep cruising along there, okay? So that's the first thing we're going to do is we're going to find our slope. And I'm going to extend my line. Like I said, I'm typically going to come up here, and I'm going to expand this. So I know that's the first term is 4 squared plus 2 times 2 times h gives me 4h plus h squared. Then I got to distribute that 2 to everything yet. Okay? Now I'm taking my limit as h approaches 0. My smartboard is not working very well again today. Of 8 plus 8h plus 2h squared minus 10 minus 5h, and then that's going to be, I don't know, that could be minus or plus. But if I came up here, I got 2 squared is 4 times 2, I get 8 minus 10. So that's really, I got in here, I got a negative 2 in there. And I'm going to come above here. I really got negative 2. So reality is that's going to be minus negative 2, which is going to be plus 2 all over h. I don't know why I put it over 2 in the beginning either. I'm losing my marbles. I'm sorry. Over 2, or h. Whoa. So from here, remember, all of this stuff is going to cancel out. So I know I got 8 plus 2 is 10, minus 10 is 0, and I should only be having terms with h's left up there. So that's going to give me my limit as h approaches 0, and I can put these two together for like terms and say 3h plus 2h squared over h. Then, because if I try to evaluate my limit, remember I'm going to get 0 over 0, so I need to solve, I need to factor out that h in the top so that I can reduce out my 0 over 0. So I can evaluate my limit now and say my slope is 3. Okay? Okay, so after I find that to be 3, what does that really mean? That really means f prime of 2 equals 3. Okay, interpretation of that? Slope equals 3 at x equals 2 on the curve. Okay, so I have my slope. Now, just so you know, if we're going to do the approximation method, because many times we can do this, okay, if it's a calculator active, what I'm going to do is I'm going to go to my calculator and I'm going to open a calculator page, and the first thing I'm going to do is I'm going to menu, actions, define, and I'm going to define my f of x function, which is going to be f of x, and that's going to equal 2x squared minus 5x. Okay, so I've defined my function. Then I'm going to plug it straight into my AROC equation, which means I'm going to give it the old control divide, and I'm going to take it from f of 2.001 minus f of 2, because that's what we're doing. We're finding the slope in a very tight interval, 2.001 minus 2, and I can see it's 3.002. All I'm going to do to confirm it's 3 is I'm going to copy that back down. I'm going to maybe add a couple zeros in there, top and bottom, so my interval stays the same, and I can see it's getting closer and closer to 3. So that would be my approximation using my calculator for that, which we will do, okay? It's not that we're always going to do this limit process business, okay? So I just found out the slope is 2. Now we want the equation of the tangent line. Well, what do we need for that? Well, in order to write the equation of a tangent line, I'm going to come down here to 2. I'm going to write 2. We need a point and slope. Okay, well remember, my f of x function equaled 2x squared minus 5x, and slope at x equals 2, because that's where they want it this time. So I just did that right here. So my slope is f prime of 2 equals 3. So m equals 3 at 2. So I have my slope. But now I need my point, okay? And my point is going to be the point on the original curve. We want an equation of a line tangent to this curve. So I need to find f of 2. So that's going to be 2 squared minus 5 times 2. I'm afraid of all these 2's. There's tons of 2's here. So again, 2 squared is 4 times 2 gives me 8 minus 10. So f of 2 equals negative 2. Remember, that's just a crafty way to say the ordered pair 2, negative 2. Now, if I'm writing an equation of a line tangent, equation of line tangent, okay, I'm going to use my y minus y1 equals m times x minus x1, okay? I'm always going to use this because I don't have any simplifying that I ever have to do on here. Okay, so I'm going to say y minus negative 2 equals m times x minus 2. I can leave it like that. I can leave it just like this for the AP test. There's lots of 2's in there. Whoa, holy crap, Kruger. I don't want an m in there. We know what m is. We said m was what? M was 3, so I got to put my 3 in there. Now it's right. Okay, I can leave it like this, or if this double negative here really goofs me up, I can say plus 2, 3 times x minus 2, or I can kick that over there and I can say y equals 3 times x minus 2 minus 2. That way I can type it into my calculator and I can graph the equation of the tangent line right in there real quick without putting it on y equals mx plus b. I can keep solving this thing and put it in slope-intercept form if I want, but I'm this guy right here because I don't want to make a stupid little sign drop. Obviously, I've been putting the wrong thing through this notebook here, but I've caught my mistakes every time, okay? Number 3. Number 3 says we need the equation of line normal. Okay, well, if you've never had physics or anything, that's fine. But they're always talking about this normal vector. And what the normal vector is the normal vector is perpendicular. Okay, so it's perpendicular. So if I have my parabola here, okay, and let's say we're at this point, what was it? 2, 3. I think that's my point. No, it's not. It's 2, negative 2, isn't it? 3 is my slope. Yeah, my point 2, negative 2. Okay. Oh boy. I'm going to be at 2, negative 2. Okay. Basically, what I just found right here, this is my equation of line tangent. So what that is my equation of my line tangent. And I'm going to come here and I'm going to make my line tangent to it. Try to make my line tangent to it. And I'm going to drag it down. Okay. Pull them in a little bit. Bottom line, no pun intended, it just touches it. It just skips the curve. Well, the normal line to this, okay, is always going to be perpendicular to the tangent line, okay? So I'm always going to have this perpendicular. So this is normal line, and this is tangent line. So what do you need to remember? Well, we need to remember what perpendicular slopes are, okay? So it's perpendicular to a tangent line. And the normal line is perpendicular to tangent line at point of tangency, which in this case happens to be x equals 2. That's how I'm going to get normal to the curve. I'm perpendicular to the curve at that point. Okay? And what I need to remember is perpendicular lines have opposite reciprocal slopes. Okay? So that means that the tangent tangent, if m equals 3, that means normal means m equals, I got it. If it's positive, it's negative, and then I got to flip it. It's a third. So, and it's going to be normal at that same point to -2. That's still my point back there that I calculated in number 2. So my equation of my line normal is going to be y minus -2 equals -1/3 times x minus 2. And there is my normal line. It's the exact same thing as my tangent line. The only thing that is different, can I get it in there? No, the only thing that's different is my slope. Up here, I got a slope of 3. Down here, I got a slope of -1/3, okay? So that is tangent lines and normal lines. They do tons of tangent lines in AP. They don't do a lot of normal lines. However, they do come up every once in a while, okay? So 2 more examples here, quick. We're going to do free fall on Jupiter. The equation for free fall at the surface of Jupiter is S equals 11.44 t squared meters with t in seconds. Assume a rock is dropped from the top of a 500-meter cliff. Find the speed of the rock at t equals 2 seconds, okay? Find the speed of the rock. This really is asking us to find slope, okay? Because if a rock is dropping, isn't its speed change in distance over change in time, which is slope when I graph this position model, because I'm going to have time, height. Okay, so I'm going to find a change in height over a change in time, or change in distance over change in time. That's why we know we're looking for slope, okay? Well, in order to do this, what do I need to do? Well, actually, I don't need to write an equation of the tangent line. I just need to find the speed of the rock. Well, what's it doing? Find the slope at t equals 2 seconds. Okay? Specifically at t equals 2. This isn't really an average slope, so what I'm going to do is I'm going to take the A rock and I'm going to take my slope from 2. I'm going to get really close, 2.001. Okay, I'm going to do the approximation. I'm not going to go through this whole limit process again. I'm going to do the approximation in this case. So what I'm going to do is, obviously, in my approximation, I need to be able to find f of 2.001 minus f of 2 over 2.001 minus 2. That is going to be my speed of the rock. So what I'm going to do is, I don't want to type in all these things. I don't want to take 2.001 squared times 11.44. No, I'm going to come down here. I'm going to use my calculator. And I'm going to say menu, actions, and I'm going to redefine a new function. And I'm going to redefine it as f of x again. And this is going to write over my old f of x function. And I'm going to say 11.44. And watch, I can even put a t in there if I want. But if I put a t, I have to define this function in t squared. I don't have to put a t. I can put an x. Doesn't really matter. So I've just redefined my function as 11.44. So now what I'm going to do is, well, would you look at that? I have my 2 point, and what it's going to do, it's reaching into my newly defined f function, and it's putting 2.001 in there, and I'm going to hit enter. Ooh, 45.7. Okay, now I need to make sure that my estimate is confident. So what I'm going to do is I'm going to come up here and I'm going to add myself a couple zeros in here. And okay, because it's changed a little bit now. I'm going to come up one more time. If I'm going to make an estimate, I need that estimate to be confident, okay? Because we do want, oh, look at there. It kind of necked it down, and it's looking at like this is going to be, it's homeroom time. It's looking like it's going to be 45.760, okay? And now this, if I'm talking about speed, I do have units. I have time and I have meters. So this is going to be 45.76 meters per second. If you have units on a problem, you have to put the units on the problem or it's not right. It's another thing you're going to also just always have to remember, okay? And the very last one, free fall, okay? I can tell by my equation, I'm back on Earth here. Okay, an object is dropped from the top of a 100-meter tower. Its height above the ground after t seconds is h equals 100 minus 4.9 t squared meters. How fast? Speed, is it falling? 1 second after it is dropped. Speed at x equals 1 second. And it's not an x, Kruger, it's a t. Okay? So if I need to find, this is an instantaneous speed. So again, if I'm finding an instantaneous speed, well, what am I going to do? It's an average rate of change, but it's on a very, very tight interval from 1 to maybe 1.001, okay? So I'm taking a tight interval. Or, remember, I can take 0.999 to 1, or I could also sandwich that little bugger and say 0.999 to 1.001. This little guy right here gives us a really nice answer a lot of times, okay? So what I'm going to do is I need to find f of any one of these three. It really doesn't matter which one it is, okay? So if I did 1.001 minus f of 1, and this is really the work, all the work you need to show me on something like this. And then that's going to give me my speed. Well, I'm not going to plug this one into the limit process again with all these decimals. Once we learn our shortcut derivatives, you're going to have this thing. You won't need your calculator, but we're not there yet. So I'm going to come back to my calculator. I'm going to say menu, actions, define. I'm going to redefine this new function as f of x. I'm usually an f of x guy. And then I'm going to say it is 100 minus 4.9x, I got to call it x if I define it here in terms of x, squared. My function's defined. Then what I'm going to do is I'm going to come up here. Did I do one with 1? Crap, I didn't do one with 1. So all I'm going to do is I'm going to give it the old control divide, and I'm going to say f of 1.001 minus f of 1, whoop, not f of 10, 1.001 minus 1, bada bing, bada boo. Look at that, 9.8. Now, see, lots of decimals in there. So I should be coming in here and I should be tightening up my interval a little bit. 9.80, looks like I've just kind of gotten to it. And I'm going to tighten it up just a skosh more. Skosh is a little bit. And yeah, it looks like negative 9.800, negative 9.8 meters per second. Now, I did say this other one, I'm just going to do this, watch, this is kind of nifty. If I took f of 0.999 minus f of 1.001, and then I take except I got my B and my A turned around here. 1.001. And all that'll do is change my sign, but I want to stay consistent here. Then I got 1.001, whoa, minus 0.999, boom, boom. It actually kind of gives me, I'm so close on both sides, it actually kind of gives me my instantaneous there. So I can see, now we got to be careful here, okay? This gives me negative 9.8 meters per second. Now, this is velocity. And we want how fast. We're after speed. So all I need to do is say, well, the rock's not moving negative 9.8 meters per second. This just means it's moving down. So the speed is 9.8 meters per second, okay? And anytime they ask you how fast is it traveling, they usually want speed. If they want velocity, it will specifically say, what is the velocity of the object at that time, okay? Should be able to finish up the rest of your 4.2 homework if you haven't done so already, and I would recommend starting your review, and you'll finish that up tomorrow, and the test is on Monday. Have a good rest of your day.